Once again, title your notes, adding and subtracting real numbers. We're still on the same standard. Once again, it's a review to get us ready for what we're going to be doing in regards to polynomials. But we're focusing on the additive inverse property, okay? We covered that yesterday, but we're also focusing on math practice standard number 5, which is using tools strategically to solve problems. Now, what tools did we use yesterday? The tiles, right? Okay. Notice that today I left them again there because look at this word in the standard. It says strategically. What does that mean? That you can either use them or not. So sometimes you can use a tool, and then once you are done using it, you can actually use just the idea of the tool. Does that make sense? Kind of like, what did we do after we used the tiles? We drew the tiles, right? And that gets us away from using this tool all the time. Does that make sense? But I still left them there so that you can make the decision if you want to use them or not. Does that make sense? All right, so let's continue. So, our objective for today, I can add and subtract real numbers. Let's read it together. 1, 2, 3. I can add and subtract real numbers. Read it again one more time. 1, 2, 3. I can add and subtract real numbers. So, yesterday I said that the main idea, also known as the concept, I write in green. The main idea or the concept is written in green. So what is our concept for today? Real numbers. And where does that go on your notes? In the box, doesn't it? The concept. So you write that in there, write it in your Freyer model. Real numbers. The objective, we already know that it goes on the bottom left. For those of you that think it went pretty fast on the screen, where is it found? On the board. On the board. It's also on the board. Okay? So here we go. Real numbers. What are real numbers? Definition. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. The set of all numbers that can be represented on the real number line. So you never the definition. Boom! Just like that. So, examples. What numbers, if you think of any number that you can plot on the number line, that's a real number. For example, -8, 23, Michael Jordan, 7.25, that also could be plotted on the number line. How about 2/3? Yeah, it's found in between 1 and 2. Is that correct? Oh, 0 and 1. 0 and 1, my bad. How about pi? Where can we plot that approximately? Near what? 3. Near 3, right? A little bit up between 3 and 4. So that's also a real number. However, what are not real numbers? You're like, wait a minute. I know all these numbers, so what is not a real number? Well, let me show you. Copy this one. Square root of -16. And I'll show you why it's not. Okay? So check this out. So we got our examples. We have our non-examples. So pens down, pencils down, eyes up here to the screen. Let me elaborate on this. Another real number is square root of 16. Why? Because we know that the word square root, what that means is what number times itself gives us this number. Do you agree with that? Yes. Yeah, right? So think about it. What number times itself gives us 16? Everyone? 4. Okay. However, there's another number times itself that also gives us 16. What is it? -4. So are these two real numbers? Yes, that's why this is a real number. But once again, what does the square root mean? A number times itself. Are we there? Yes. Now, with that said, what number times itself gives us -16? Boom. I said, what number times itself? There is none, right? So if there is none, then this is not a real number. This has a specific number. Now everybody look up. Everybody's seen this before. Look at me. Who's seen this before? Who's seen that as imagination, right? Well, guess what? This number is called imaginary number. This is an imaginary number. So write it in there. Imaginary number. Because if it's not real, guess what? It's what? Imaginary. Does that make sense? And guess what? When you get to Algebra 2, you're going to go over and work a lot with imaginary numbers. I'm just introducing this to you today so that you have it in mind. So students, imaginary, students. There you go. Pretty good? So, what's so important about real numbers? Well, the critical attribute would be that it's all numbers on the real number line. All numbers on the real number line. Straightforward, yeah? Okay. All numbers on the real number line. Now, who noticed on the objective I wrote a symbol on the objective for today? That's a symbol for real numbers. I forgot to re-emphasize that with my other class, but here it goes. So let me rewrite that. I'm going to write it here next to the term real numbers. I'm going to do that in green. The symbol for real numbers is like this. That's what real numbers stand for. This is the symbol for real numbers. So write it in there, have it in mind. We got it? So, we have our definitions. Now we know what real numbers are. Let's move on. Yesterday I introduced the additive inverse property, yes? Okay, there it is. Today I'm going to add a couple methods of adding and subtracting real numbers. Last year your teacher showed you guys this method using the absolute value to add or subtract. Remember that? Some of you yes, some of you no. I think I had too many enchiladas over the break, so let me go over this really quick. Pens down, eyes up here. It's just a review. Here it goes. To add these two using the absolute value, check this out. I'm going to start with this one. And it goes like this. Take the absolute value of the first, that is 8. Absolute value of this one, 12. Check to see if they're not the same sign, we're going to subtract. Remember that? So I start with a big absolute value. So what is 12 minus 8? 4. Once you're done, you look at the greatest absolute value and go see the sign that was originally related to that. So what is the original sign? Positive. That one stays a positive 4. See how that worked? Remember? Is it coming back? Yeah. Let me go over this one. Absolute value of 3 is 3. Absolute value of negative 15 is 15. Are these the same sign? No. That's why I'm going to subtract. 15 minus 3, that's 12. What is the greatest absolute value? 15. What is the original sign? Negative. That's why this is a negative 12. Is it coming back? Yes. So that's when they have numbers that are opposite signs. But what if they are same sign? Let me go with the same sign. Absolute value of 3 is 3. Absolute value of 6 is 6. If they have the same sign, we add. And then we just attach the original sign of both numbers. What was the original sign? Positive, so it stays a positive. So far so good? Absolute value of negative 2 is 2. Absolute value of negative 9 is 9. We add because there's the same sign, so it's 11. But what is the original sign for both? Negative. That's why you attach that sign. Are we there? So we're going to use this method. And this is the thing, guys. If I was to teach you just the way I like to teach, like only or the way they taught me, only one way, I'm not giving you guys options to make your own decision as to which method to use. Does that make sense? If I was only to teach you one way, then you would be like, man, I would like to have another way. Give me a second. Mr. Q. Anyway, So with that said, so today I'm going to give you 4 different methods of, we already started with sum, and we're going to continue today. We're going to have 4 different methods to add and subtract. Okay, so with that said, check this out. We're going to get to this problem at the end. Don't write it down. I'm just showing you what kind of problems involve positive and negative numbers. So you see that this one has positive and negative numbers. However, if we just write it out, it won't make a lot of sense. What I wanted you to think about, though, this is negative 247, yes? Yes. But they want us to figure out the height, which means the whole thing, which in a sense they're talking about a distance. So, can we use negative numbers at the end to write a distance? No. So what process shall we use for distances? Keep it to yourself. Keep that question in there, and then we'll come back to it. Okay? So here we go. Who notices underneath your Fourier model, the box, there's like 7 empty lines. Do you see that? Okay, copy these steps down, please. To add real numbers, step number 1, represent each number on the number line, comma, with tiles, comma, ground 0. Did I cover ground 0? Yes, right? We introduced this here with that. And then as an expression. Step 2, identify all 0 pairs and use absolute values to add the expression. And step 3, simplify. Copy that, please. For those of you that are already done writing this down, could you circle the first word of each step so you can remember the steps a lot faster? First step, we represent. From there, we identify. And then at the end, we simplify. So first step, we represent each number on the number line with tiles, ground 0, and as an expression. Now, as an expression, we need it as an expression because we need to use this rule, using absolute values. That's why it needs to be written out. Okay? And we already know what to do with 0 pairs, right? When we use the tiles and stuff. And at the end, we simplify. Okay? Are we there so far? Now, what was our objective? Our objective is I can add and subtract real numbers. But what are the steps for? What are the steps for? To add real numbers. So what happened to subtraction? So pay attention. Eyes to the board really quick. You'll finish copying right now. Give me a second. So these are the steps to add. If I was to give you steps to subtract, let me give you something to look at. Don't copy these down, just look at it. That's to subtract. Let me take you back to the steps to add. To subtract. To add. To subtract. To add. To subtract. To add. To subtract. So you never what's different. Who saw that there's an extra step for subtraction? What is that step? The very first one, which is a rule. This is what we call the additive inverse property, but now applied to subtraction. Therefore, notice on the left side of your notes where you wrote the steps, is there an empty space on the Q side? Yes. So therefore, on the empty space, I want you to draw an asterisk, a heart, so we can remember. And then you're going to write to subtract comma, and then you write this step. Add the opposite of the second number to the first. Add the opposite of the second number to the first. Add the opposite of the second number to the first. Add the opposite of the second number to the first. Add the opposite of the second number to the first. Add the opposite of the second number to the first. Add the opposite of the second number to the first. Add the opposite of the second number to the first. Add the opposite of the second number to the first. Add the opposite of the second number to the first. Add the opposite of the second number to the first. So when we subtract, tell your neighbor what to do. Yeah, right? You guys already know that, but I'm going to show it to you again so that we can revisit. Okay? Alright, so let's continue. This is how they look side by side. Notice that each of them have these 3 steps, but this one has that extra step. Really, Fly? My goodness. Alright. With that said, turn your paper over. In the back, at the top of your page on the left-hand side, write example 1 and write the instructions. Add or subtract using a number line, comma, tiles, comma, ground 0, comma, and absolute value. So we're going to add or subtract using those 4 different methods. Which is the one we did last night? Using what? Tiles. Let's do that one together since we already know how to do it, right? Now, like I said, you have the tools in front of you. You can use them if you want. If not, then I want you to draw it underneath if you're not going to use those, okay? So what would it look like if I was to draw this? What do I start doing? 3 negatives. We got 1, 2, 3. And then 1, 2, 3, 4, 5, 6, 7. Circle what? Circle the 0 pair. Cancel it out. And that leaves us with what? 4 positive. Yes. Oh. Alright. So with that said, I want you to do this. Draw a line across like this. And underneath, we're going to draw a number line. Check this out. This is the second way that I want you to add or subtract. Draw a number line. And this was, I think, introduced also last year, but I'm just refreshing your mind. We're going to use all the methods today. So, in order for us to add or subtract using the number line, it is important that we always start from 0. It is important that we always start from where? 0. So I want you to draw 0. Here's 0. 0. There it is. And I'm going to use red for negatives and green for positives. So I'm going to box my first number as -3. I start at 0. When it's a negative, I go to the left. When it's a positive, I go to the right. So here we go. How many steps to the left? 3. So I go 1, 2, 3, and I land at -3. However, my second number tells me that it's 7 steps to the right from where I land. I landed at -3, so I take 7 steps to the right. 1, 2, 3, 4, 5, 6, 7. And that brings me to +4. You box your answer. That's the second method. See how that worked? Yes, Mr. Q. Good. From there, I want you to draw a line down like this so we can make it a 4 boxes. You see the 4 boxes here? So we use tiles for this one, number line for this one. Here, we're going to use this space for ground 0. Ground 0. So let's see. I'm going to draw my ground 0. There it is. And we start by digging a hole. How deep is it? -3. -3, okay? However, we bring how much dirt? 7 of dirt. Okay, so we bring 7 of dirt right here. So, is this 7 going to fill the entire hole? No. It's not going to fill the hole? Yes, but we're going to have left over, aren't we? Left over what? Hole or dirt? Dirt. So check this out. To indicate that, I want you to do this. You're going to do that, put a shade, and how much dirt are we going to have left? 4. And you bring the 4 and you write it on top. Whenever there's a hole left over, where does the number go? On the bottom. So to indicate that it's a negative. Are we there so far? And the last method, using the absolute value. I'm going to rewrite this. -3 plus 7. Let's do that right here. So let's start. What is the absolute value of negative 3?
3.
3. Absolute value of 7? 7. Are they the same sign? No, so what do we do? Subtract the absolute values. What is 7 minus 3? That's 4. Circle the greatest absolute value, which is 7. And what was the original symbol for 7? Positive, so we're done. Did we get positive 4 for all methods? Yes. And that's how we see that we actually can solve or add and subtract using 4 different methods. Are we there? Okay. I'm going to give you one more. Do the next one by yourself. Ready? Example number 2. You don't have to write the instructions anymore. You already have them. Here we go. Example number 2. Copy this down, please. Yeah.
Any example we want to say, like ground zero or that?
We'll get to that. But for right now, I want you to do all 4 methods. So, example number 2 says, you don't have to copy the instructions, but we're adding and subtracting, and the numbers that they give us is negative 4 plus negative 7. I want to see all 4 different methods. Go. Okay, here we go. I'm going to start with tiles. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Do I have any 0 pairs? No. Therefore, what do I have in front of me? Negative 11. Hands if you got that. Okay? From there, I'm going to use a number line. For the number line, it's imperative that we start with 0. What does imperative mean? Necessary or important. So, we start with negative 4. Starting from 0, 4 to the left, 1, 2, 3, 4, and I land at negative 4. From there, it tells me to go, 7 more steps to the left, but from here, 1, 2, 3, 4, 5, 6, 7, and I should land at negative 11. Did I get the same thing as here? Yes. So far so good? Yes. From there, ground 0. Here's my ground. I start with a hole that is 4 deep. There it is. But then they asked me to dig how many more? 7. So if I don't have any dirt, how deep is this hole? Negative 11. Does that make sense? Okay, and then the last one using absolute values, negative 4 plus negative 7. So, let's see. Absolute value of negative 4 is 4. Absolute value of negative 7 is 7. Therefore, if they're the same sign, we add. This becomes 11. But what is the sign for both of these numbers? Negative, and that's how we get negative 11 for all 4 methods. Everybody got it? Okay, so the next one, as you requested, I want you to do problem 3B. Leave me 3A. I'll guide you through that one, but 3B you're going to do by yourself. You choose any method of the 4 and add me those numbers. Here we go. You're working on 3B. Choose any of the 4 methods and find me the sum, please. Go. Negative 6 plus negative 2. Choose any of the 4 methods. Find me the sum. Okay, volunteer. Yes.
Okay, I did the absolute value method.
Absolute value method, okay.
So I wrote the problem out and I did the yeah. So I put absolute value signs on each side of the both numbers, and then I said 6 plus 2 equals 8. And then I looked at both the numbers, what the signs were, and then got the equal negative 8 because they're both negative.
Thank you. Hands if you got negative 8. That is correct. So just to elaborate, she went ahead and put absolute value in both numbers. She got the absolute value of both numbers since it was the same sign. She added 6 plus 2. And then she looked up to see that they were both negative, so that number becomes a negative. Are we there? And any method works, right? Okay, let's go to this one. I'm going to show you a couple of methods for this. And probably the easiest one is this. Whenever you get to these, copy example 3A, copy this, and then I'm going to walk you through that. It's negative 3/4 plus 1/4. So, first way of doing this. The first way is identifying the common denominator. What is my common denominator? 4. So I write the 4, and from that point forward, I'm going to ignore the denominator. Check this out. Therefore, I'm going to cover up the denominators You can do that with your finger if you want. And that brings you to their attention of the numerators. Who sees the numerators? I have -3 and +1. There I'm going to use tiles. How can I represent that? 3 negatives, 1 positive. Do I see a zero pair? Yes. What do I have left? -2, and can I simplify? Yes, -1/2. Copy that, please. You're like, man, that was easy. I know, right? So that's one method. Now, I'm going to take you back to elementary to, let's see, fractions, 3rd grade. Yay! Remember when they used to serve you guys sloppy joes and stuff like that? All right, here we go. So, so your teacher, I'm pretty sure they introduced fractions using area models. Remember, squares and circles and dividing them into sections. Remember that? So check this out. We can use that same method. I'm going to use a square, and I'm going to divide it into 4s. And I'm going to shade with my red, because it's a negative, how many of these squares? 3. Okay? This one, I'm going to also draw my square, divide it into 4s, but I'm only going to shade one of them, and what color? Green. And what do we know about red and green?
Positive and negative.
So what is that? A positive and a negative are opposite, is also known as 0 pairs. So that means this cancels this, doesn't it? And what do we have left? 2 boxes out of the 4, which is 1/2. What color is it? Negative. That's cool, huh? Anyways, that's another way of doing it. I'm just showing you stuff that you did in the past, but it also applies. Are we there? All right, copy that, and then we'll move forward. Here we go. So we got addition down pretty well, okay? I'm just going to show you a couple of subtraction ones. Here we go. I'm going to leave that up for about 20 seconds. So we know addition. We got this also. We move to subtraction. Copy this one, example number 5. Example 5, copy, subtract 5 minus, parentheses, -4. Okay? Once you copy, pens down, pencils down, eyes on the screen. I'm going to go over this one. Now, we did all that work for addition. We know the 4 methods, how to solve different methods and choose your own method and so on and so forth. But now we end up with subtraction. What did we say? Think about it at the beginning. What did we say was the difference when subtracting from addition? What was the only thing different? Tell your neighbor the rule. Add the opposite of the second number to the first. This is how this works. Everybody look up, please. Don't write anything down. Pay attention. Focus. So, add the opposite of the second number. The opposite is a to the first. Which is the only one that didn't change? The 5. So just remember that. When you get to subtraction, the first number does not change. So the rule is add the opposite of the second number to the first. So what if I had this? Check this out. Which one doesn't change? The first one. But the rule is add the opposite. As soon as you see subtraction, add the opposite of the second. Here's my second number. What is the opposite of 4?
-4.
Do you guys see how that worked? Copy those 2, please. And by the way, after that, do we know how to add these numbers? Yeah, right? Okay. Finish off these 2, any method. Alright, so for this, what do we get? 9, and what do we get for this? 1. Okay, and like I said, any method works. Is that correct? Okay, so let me give you another one, see if you can do that one by yourself. Here we go. Copy this one. Example 6. Subtract 13 minus 21. Use the rule, and then you choose any method. So, let me get the randomizer to get somebody to help me out with this one. How about Julia? Opposite of 21, which is negative 21. You add that to 13. Hands if you did that. Yes, because the rule is, what? Add the opposite of the second number to the first. Okay, and which method did you use after that? Okay, but which of the four methods did you use? The tile. Okay, so you drew 21 negatives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 13 positive. 5, 6, 7, 8, 9, 10, 11, 12, 13. Circle your zero pair. And we're left with what, everyone? Negative 8. Okay? Yeah, that works. What would be your, let's see, who chose absolute value process? How about integer tiles? Ground zero? Number line? So absolute value. Now, some of you are saying, Mr. G, I'm not using any of the four, but in your brain you are, in a sense. You're using which one? This one, right? Because your brain already automatically understands that you need to do what? Get rid of zero pairs. Is that correct? I know, right? Now check this out. Before we leave, look up, please. Let me go to the iceberg dilemma. It starts with a height of 75 feet. But they want the entire distance from here to here. So what is this distance right here? Negative 247. Is that correct? Yes. But if I use these two as they are, I'm going to end up with a negative number. But we know distances are not measured in negatives. So what can I do? We do what? Add the opposite. Or how can we change this into absolute value? So whenever you're looking at distances with negative numbers, you plus the absolute value of the second. That's going to leave us with 75 plus 247, and that gives us a sum, right? So for homework for tonight, you have worksheet 1.2 on add and subtract, and it's on your way out. So turn in your homework on your basket on your way out and grab one of those sheets. Have a good one, everyone. Enjoy your homework. See you guys tomorrow.